All right, so just before Rob gets into this, I just want to say the motivation behind this is that, well, first of all, the large software development project we're on now, Brown Dog, but also we have a number of software development projects, a lot of them actually. And so the size of the group has just gotten to the point where we kind of have to do these things to structure ourselves a little bit better. And so a lot of the things I think Rob's going to talk about are stuff that a lot of us are already familiar with, probably some of us more than others. So it's more or less review, but I think what's important is that we're establishing what we will do here in this group and on Brown Dog in terms of software development. This is the way we're going to do it, because there are many ways one could do it, and this is the way we'll decide to do it. So on that note, I'll pass it over to Rob.
Okay. So what I'll be talking about today is a presentation I worked together with Luigi and John on making, and it's just the presentation is more based on some of the experiences that we've had over the last couple of months doing a couple of these software practices ourselves and with some of the other projects I've worked on. So it's still work in progress, but it's something that I'd like to start proposing that we use. And if there's any comments that people have, we can take them up and we can try to see if we can fit them into the workflow that I'm proposing here. So first, software practices. I love Wikipedia. They have lots of interesting quotes on there, so you'll see Wikipedia appearing a lot. It's a set of informal rules that the software development community has learned over time to improve the quality of applications and simplify their maintenance. The key word there is these informal rules, and I'm trying to, with this presentation today, make these informal rules more explicit so that we all know. It's not that I assume everybody knows these rules, but that we actually have these rules and that we try to follow them, because I think it will help our software. It will make it better, it will make it more stable, and it will hopefully just get our stuff out there in the world for people to use. So it's not something new. People have been working on it, and Luigi pointed to a good book here, The Cathedral and the Bazaar. It's the difference between a, I guess, closed source or closed source and an open source project. Or the idea being of the cathedral is this big thing. The source is released between releases, but in between the releases, the source is closed. Only a handful of people can work on it. And so all of a sudden, bang, you get a whole new big set of changes, and this is the big new thing that you're supposed to be working on. The Bazaar, the source is available at any time. It's public. And so people, it's like the bazaar that you are there. People walking around, browsing, looking at it, trying to pick things up, trying to look at things, trying to get familiar with what's there. And I believe, and this is, I think, also this is what the Linux kernel is based on. This is a better model than the cathedral. I think it fits us better. I think you end up with better software because from the beginning, people are looking at your code and commenting on it and getting it better. Then at the end, all of a sudden, it's out there and people feel like they cannot change it anymore because it's a release. So, in there, they talk in the book itself. They have 19 lessons that they talk about. Good programmers know what to write. Great ones know what to rewrite and reuse. It's relatively easy for us, I hope, to write code. All of us are coders, all of us are programmers, all of us know how to program. It's easy to write code, and we can all write pretty good code. The interesting and challenge is to know when to reuse somebody else's code. Don't reinvent the wheel. You know, there's lots of things out there that we can reuse. But sometimes something is so bad, it's worth throwing it away and rewriting it. And that's something you have to know when to do. Like I said before, with the Bazaar, release early, release often. Don't hold on to your code until it's perfect. It doesn't work that way. People will find bugs and you will feel kind of annoyed for having waited so long for people to give you feedback. And besides that, if you release often, people see the new features, get to play with it, they get excited about playing with it. That's what we want. And if we have a large enough set of beta testers and a not large enough set of code developers, every problem will be eventually found and fixed. You know, If many eyes looking at your code, eventually everybody will have looked at every single piece of code and everything will be fixed. Now, probably not going to always happen, but the more people look and work with you, the better your code is going to be, the earlier you find your issues. So the key thing that I'm hoping to get you to realize today, software development is a collaborative effort. It's not something you do by yourself. Now, up until recently, our group was small enough that we could work by ourselves on a little project. It's no longer the case. We have a couple of really large projects that we work on. Brown Dog is going to be one. There's Medici that we work on. There's lots of places. I work on Pecan, which is used in lots of places. A lot of our software is used in many places. We are no longer working alone. It's a collaborative effort. But the good thing is that we start sharing the code. And when we share the code, many eyes will look at it and it will make it better. Right? It's a collaborative effort. We need to all look at the code. Even inside our group, if we work on a project, it's good for somebody else to look at your code as well. Because they will find issues that you didn't think about. And I'll show you a couple of examples where it's a trivial little piece of code, but somebody looking at it will find and point something out to you that will make it better. So here's a very simple view of it. And this applies to a very small level, the low level, where you do like one iteration yourself, up to all the way to like a release. You know, the same mechanism works with all the micro and the macro levels. First, you write your code and you write tests. Sometimes these two things are flipped around. Some people like to write their tests before they actually write their code. Some people write their tests after their code. The important thing is you write new tests for what you did, and you check the old tests that are there. And both need to work. The code and the manuals need to be documented. You know, the code is really easy to write. Documentation is hard to write. The documentation is important if you have lots of people working on your code. Manuals, I can't reiterate it often enough, but Java doc is not enough. If I just write Java doc, it's not enough for somebody to understand what your code is supposed to do or how it's supposed to be used. There's this larger picture that is not written in Java doc that we need to get out there as well, and this is where the manuals come in. Publish, share your code. Send artifacts to a central repository so other people can reuse them. Again, you see here, the reuse comes into play. Make an artifact, have somebody else reuse it. Don't have them reinvent the wheel. Once you're done, get feedback on what you've done. Code reviews, user interviews, mailing list, everything else. And once you're done with that, you go back to the top again and you start coding again. You start with the next cycle. Now, like I said, this could be a small feature you're working on. This could be a full release that you're working on. In both cases, you should try to follow this development cycle. So I could go a little bit over the software tools now that we have in our group. So this is sort of like an introduction of why I think software practices are important. Now I'll go a little bit into the software tools that we have. There's many IDEs out there, integrated development environments. We use Eclipse in our group primarily, and that's what I'll go over in a little bit. We also use Sublime, I think Node.js, Emacs, CI, you name it, somebody's used it, and somebody will still use it. Eclipse is very powerful, and that's why I will go into a little more detail. Languages, Java, Scala, PHP. My tendency is I'll try to use whichever language fits best to my problem. I will not take a hammer and what's it, hammer and screw or something like that. I will try to find the right tool for the right problem. If I am going to write a kernel driver, I will not write it in Java. I will write it in C. It just works better. If I need to do a lot of web development, there are probably good languages like Ruby on Rails for that one. If that fits your model. If it doesn't fit, maybe Scala is a good one. We start using Scala a lot. Source code management is not a maybe. It's a must. And I'll go a little bit into Git and SVN, but please, 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 please use source code control. I don't think that should be an option. And then build tools, they'll make your life easy, they'll make other people's easy. It's too often where people say, oh, you just run these 27 commands and it will compile. You know, if there's all these commands you need to execute, write them down into a makefile, in an end script, in the Maven project, but so make it easier for other people to know how to compile it. This is part of your documentation. If people have questions at any point, just ask them, Richard or anybody else online. You can just type them into the messages as well. I'll see them. They're displayed here as well. So, Eclipse. We use it in our group a lot. I ask people to install it as well, so we can play a little bit with it later. It really is a Swiss Army knife. If you have a programming language, there is probably a plugin for that programming language to help you with it. The website I list here, and I'll send out the slides later, but the website I'm listing here is has a good introduction to Eclipse. It's a long introduction to Eclipse. In general, the guy Vogela, I think it's pronounced, does an amazing job of writing Eclipse tutorials. He has like at least 20 or 30 tutorials online. They're all freely available and they're all very well documented. He keeps them up and he gives seminars and everything else. So it's basically his business, but he puts them freely available. Actually, the one thing I should mention is that if we have any problems, we can always ask Chris to fix them since he's an official Eclipse developer now. So, but and so probably if you have questions, he'd probably be a good one to ask as well because he works a lot with Eclipse. A little bit of the history because it's sort of interesting because this is a large software project and I think it fits where we are. It was initially developed by IBM. It replaced Smalltalk-based IDE that they had internally. It was closed source. They decided to use Java. And in 2001, I think they started this around 1990 or something like that, or I forget exactly. But in 2001, they decided to make Eclipse an open source, and they made it into a consortium. At that point, really, I think, is when Eclipse took off. So it's sort of interesting. They went from this closed source project that they used internally to this open source, and now this is this massive, big project that a lot of people work with and work on. In version 3.0, they started using OSDI, which is a plugin mechanism, which makes it easier. And starting Eclipse 3.2, they started giving code names to Eclipse as they started having what they call release trains, where everybody that has all the different plugins that people have that they want to release basically say, yes, we're ready for the next, or the next release will be at this particular date. And everybody has to be ready with their plugins at that particular point. And so they released this whole new suite of software that all fits together and it's all at the same version. So right now they're at version 4.3, which is called Kepler. And somewhere in, I believe in June next year is when they release the next release train. I forget what the code name is, but that's basically where everybody has to have their code ready. They're no longer allowed to make any changes, and it gets released as one big set of packages that go together, but they all fit together and they all work well together, and they've all been tested together. As I said, Eclipse is very extensible. It's plugin based, which is really the OSGI framework that sits underneath it. Eclipse, what we see is a very small little kernel. It's only like a couple of plugins. Everything else that we use, the GUI, the different programming languages, the source control, everything else are plugins on this little kernel. The plugins are installed using P2 these days. It's a dependency management system and it allows for easy for upgrades. It also makes sure that if you install a particular plugin, all the dependencies of that plugin are installed as well. So you cannot install a plugin inside your Eclipse environment and have it be broken because you're missing a whole bunch of dependencies. The plugins can change all aspects of the clips. You can add new programming languages, like I said, you can add new views, you can add new perspectives, and I go some of these terms in a second. But basically, everything that you see in the clips can be changed using these plugins, including the menus, including the pull-down menus and everything else. Common workflows that people use Eclipse for, of course, code editing, that's why we use it, debugging, and source code control. And all of these are very well done and work really well. Here you can see one of the reasons why I am slowly moving away from SVN to Git is to be able to use SVN in Eclipse. It requires you to download an extra plugin, which always takes a lot of time to explain to people. You have to go here, download this, do this, click here, and sometimes it works and sometimes it doesn't work. So it makes for a good reason to slowly move to Git. Here's a list of languages that I've seen and used for development: JDT, Java Development Toolkit, CDT, C++ development, PDT, Scala, Statlet, which is R development, Python, Ruby, Android, Google Web Toolkits, everything else. There's a lot of them. Actually, I found recently there's also a Node.js plugin for it, so you can write Node.js code in here. And it's really, if these are done correctly, they make your life tremendously easy. They have code completion, they have highlighting of syntax and syntax checks often in there already. So it makes your coding a lot more easier. So look at this list, see if there's your programming languages here, and you probably can find the specific plugins that are needed for it. If not, I can probably help you find some of them. Before we start really working with Eclipse, there's some terms that people will use and that are sort of assumed to be known, and actually took me a while to actually get them and to understand them. So a view is used to work on data. It shows a hierarchical overview. So for instance, the outline of your source code, all the function names, all the files that are in a folder, all those are captured inside a view. Views are actually not usually, views are read-only. You cannot change a view. Well, let's see. You cannot change anything in a view, and if you do, it's immediately saved. There's no dirty state. Editors, on the other hand, are things that can have a dirty state. So, for instance, in Java code or any other languages, the editor is not saved until you hit explicitly save. And so they made a very clear distinction between these two. There usually is only one editor open at any time. There's many views open, but the views usually operate on the editor. A perspective is a grouping of views and editors, and this includes how the layout is. So people basically say, here's my perspective on doing code editing, have said, here's the different particular views that we want, here's the editor, here's all the other views that we want, and this is the layout that we want for you to have. So if you've opened Eclipse, you will notice that if you go into the Java environment, it will have already on the left side all the files that are in your project. On the right side, we'll have the outline of your code. In the middle, it will have the editor. And so this is a perspective. And people have looked at it and tried to set it up so that it's easiest for you to accomplish your task that you're trying to do. A project, on the left side, usually you will see a list of projects. This contains all the source and binaries that belong together. And they often form a single buildable unit. So if you look at it, oh, sorry, Kenton, it's Polyglot is a unit. Medici is a unit. Versus core is a unit, not versus. Versus core is a unit. Versus audio is another project. All those little units are projects. And then often you have a workspace where you keep all these projects together. So people tend to have, at least I tend to have, many different workspaces for the work I'm working on. So if I work on Versus, I will have my Versus workspace with all my Versus projects. If I work on the Cyber Integrator, I have my Cyber Integrator workspace with all the Cyber Integrator projects. This allows me to focus on the task at hand. And if I have all the different pieces there, if I have all the different projects that I work on, I have so many projects on the left side, it actually becomes impossible to find anything anymore. and B, it's too easy to switch quickly to something else that might not be relevant to my task that I'm working on. So really, these workspaces help you to focus on what you're trying to do and to try to accomplish. So here's, for instance, a picture of the Java editor. In the middle, you will see the editor. On the left side, you see a view with the projects and all the files that are in there. On the right side is the outline that shows you all the functions that are in there. Actually, this is Scala editor, sorry, take that back. And on the bottom, you will see a different set of views that either show you the errors that you have or the console outputs and things like that. Things that you can easily switch between, but you don't want all of them at the same time. Views, like I said, influence other views, often the editor. So if I click on the outline, I click on a function name, it will actually jump the editor to that particular function name. Most languages have this. So it will make it really easy if you need to go to a particular function, you just click on it and it jumps to the right function. On the left side, you'll have the package explorer. You double click on any of the files in there and it will actually jump you straight into that file, open that file in the editor. So here's the package explorer. You double click on a folder, it will open the folder. If you double click on a file, it will open the file. You notice that next to the files there is a little triangle as well, which allows you to open it. If you open that, it will actually show you the functions inside that file. If you double click on the function, it will open the file in the editor and immediately jump you to that function as well. So it's really powerful. The editor is neat. If you start working with it, it makes life a lot easier. Things to notice is that in this case, there's a little asterisk. I don't know if you can see it. You can see there's a little asterisk in front of the first tab. That means that the file in that editor has not been saved yet. So it's in the dirty state. You will notice that on the right side, it has little red and blue ticks in the scroll bar. The red ticks are errors that are in your code, and the blue ticks are to-do comments that you have in your code. So again, you can click on any of those red ticks and it jumps you straight into that particular point in the editor. Get used to using these. It makes it really easy to jump around your code and fix it bugs. On the left side, you will have the same blue and red marks again. This time it only shows you for that particular piece of the window that is visible. Especially if you start having lots of little red marks or blue marks really close to each other, basically gives you a zoomed view of all the check marks and errors that you have. Control space is code completion. So if you start typing in Java, it will show you all the different functions and methods you have on classes. As I said, it just makes your life easy to start using Eclipse. We use Java in our group primarily, and we started to use more and more Scala for Medici and for other web applications. I think they're helpful. Actually, Node as well a little bit. Right? See again? No? Okay. So primarily Java and Scala. I list some of the. If you haven't done any Java development, the first one is a very simple tutorial. It's a bunch of tutorials that help you get used to Java. Stack Overflow, really good resource. Yeah, I use it a lot. There's a lot of good people there. If your question is not asked yet, you can ask questions. People will help you. Scala, again, I gave you a link to a set of tutorials for Scala. They're good. The second link I give is this cheat sheet I found for options. Options are really powerful use in Scala. It basically avoids you from having null pointer exceptions because you cannot not use a match statement. You have to check to see whether or not your option actually is a value or not. The cheat sheet that I list here allows you to, shows you all the different ways that you can, instead of having to do all these case match statements, to make it easier for you to write one line and get the right answers out of it. And I put it here because I keep going to this particular place again to find the right cheats to use. So I think I might as well post it here. Source code management. So any questions about Eclipse and Java and Scala? I can spend many hours talking about Java and Scala. I figure I'll give you a couple of links, and if the questions just come by or send me an email. Richard, Chin, any questions? If not, I'll just keep going. Source code management. As I said, source code management is not an option. Sorry. We are in a large group. Other people, I want other people to look at your code because they will help you find issues. For them to be able to do it, sending an email with your source code doesn't really scale. Source code management allows you to share your repositories with other people. Other people can look at it. If you make a mistake, you can easily go back. And it's just, it's not an option anymore. There is no excuses. There's so many of these GitHub stacks that we have locally allow you to easily set up repositories for you to check in your code. Source code managements have existed for decades. One of the first ones, SCCS, developed by Oracle or by Sun. In 1972, from SCCS, we went to RCS, to CVS, to SVN. So far, these have been centralized systems. We have a single repository where you check in and check out. There's only one master copy. Around 2003 or so, the Linux kernel moved to a centralized repository, to another repository system. They liked it for a while, and there were some issues with the person that maintained it. And around 2005, Linus Torvalds says, I can do better. And he wrote Git. At the same time, I think Google? Google? It's around the same time, it's actually interesting, around the same time, Git, Mercurial, HG, and Bazaar, all three were developed around the same time, all around 2005. These are distributed version control systems. Everybody, in these cases, everybody has all the code at all the times. So I have a complete copy of the repository on my local machine versus SVN, where the copy sits on the master node somewhere. You only have the files that you need. We are moving towards Git. Most of our repositories that we have transferred into Git repositories. There's some places where we still use SVN. Sometimes because we cannot make it a public repository, and it's just sometimes easier to set up an SVN repository for these cases. But I think we're moving more and more toward Git, and I think that's going to become the standard. As a matter of fact, it's so. Quick overview of the difference between Git and SVN. Git, all repositories have all the history. When you download a repository, you download the full Git history. You have everything on your local machine. SVN, only a centralized repository has all the history. What you download is a working copy. You don't download only that which you need. Git, I can work offline. I can take my Git repository, go on an airplane for 8 hours, fly to Korea, and just keep working. I can do check-ins, I can do checkouts, I can do, I can roll back, I can do all those things while I'm sitting in the airplane. SVN, I can work offline, but I cannot push anything. I cannot commit anything. So I'm sort of stuck here where basically I have my changes. I might want to do something really destructive. I have no possibility of doing quick commit to basically say I'm going to do something destructive. I cannot easily switch to a different branch or something to fix another bug. Interesting thing, the SVN, they looked at the Mozilla SVN repository. They got a 30 size decrease when they switched from SVN to Git. Just the way things are being stored. So it's significant improvement there. Of course, the disadvantage of Git is, like I said, you You need to get everything. You cannot just get a single file out of a Git repository. SVN, you can actually just go and fetch a single file out of it or a single folder out of it. Git, you have to fetch the whole Git repository. SVN branching is hard. Actually, it's possible, but it's hard. And when you do a branch, when you check out a branch, you check it out usually out to a complete separate folder, and that's where you're working in them. Git branching is easy, and it's good because I want you to use branches. We'll talk a little bit more when. But branching is easy, it's fast, it's quick, and you can quickly switch between branches. SVN was the standard a couple of years ago. Everybody used SVN. Everybody had moved from CVS to SVN because it was better. Git has become the standard, very much. Mercurial and Bazaar are there, but I think with GitHub, Git has pretty much become the de facto standard for people to work. So, a little overview of Git. Git has a local and a remote site. When you initially clone it, you make a copy of the remote Git repository to your local machine. You copy over the full Git repository. At that point, you have a local repo. When you work against that local repository. So, in your working folder, you have your files, you work on your files, you change them. Once you change files or you change files or you add new files, you add them to the repository. What they call it at that point is you put them in the staging area. They're staged to be committed. They're not committed yet. They're just staged, they're just marked as needed to be committed. When you do actually the git commit command, you actually commit them to your local repository. At that point, they're in your local repository. Now, you can easily roll back again. You can undo your commit. You can take your check files out. You're the only one that has access to each of them. Once you're done with it and you're ready to give them out to everybody else, you do a push. You push them out to the remote repository. And at that point, everybody else, when they do a sync with the remote repository, they will get your changes as well. To get your data from the remote, to get any changes from the remote repository, you do a fetch, which fetches the changes on the remote repository or your local repository. This is important. They're sitting in your local repository. They're not sitting in your workspace yet, in your working directory. So they're sitting in this secret database that Git has in your folder, but they're not merged yet with what you're doing. So you can do a git fetch at any time you want. It will not change your code. It will just make sure that you're in sync with what is on the remote side, on the local side. And when you do a git merge or a git checkout, you will actually get the changes that are there. Now, because a lot of people do git fetch, git merge, they made it easier for you. It's just called git pull, which is the opposite of pushing. You pull your changes into your local working folder. And I think this is sort of important. So let me take a stop here, make sure that people understand Git, this picture of Git here. Because I've drawn this, I don't know how many times on the whiteboard so far.
If you come from SVN, this is easy for
If you come from SVN, really there's only a working directory and a remote repo. The yellow and the blue part are missing. Okay. Now, because Git is very flexible, you can do many things, and so there are many different Git workflows. The one that we've been using in our group, and which we've started this with Medici, and then we put it on Cyber Integrator as well, and I think we're going to put it on more and more projects, is this integration manager workflow. The way it works is many developers clone the central blast repository. This is a central repository, everybody clones it. At that point, you have the repository sitting locally on your machine. You work on it. You write code, you check it in, you do commits, everything else. You do pull requests to get the data from the remote repository or local repository. You work there. Once you're done with it, you actually push either to your own personal remote repository or to a centralized remote repository. What we did specifically in Medici and Cyber Integrators, we limit the number of people that can write to the master. So you can write your own branches into a remote repository. I'll go a little bit more about that in a second. But you cannot write into the master repository. So that means that anybody comes by and does a clone of the repository, the master is checked and is known to be working. And this is really cool. The way the integration manager works is when people say, I am done working on my particular piece, I'm ready for you to take my code and push it into the master branch. So people say, I'm done, and they say, can you please take this and push it into the master, because I can't. So the nice thing is the integration manager is sort of the first set of eyes that looks at your code. They'll look at it and says, yes, this looks good. And I'll put a little check mark and say, looked at it, a little code review, push it into the master branch. At that point, everybody else can check out the master branch and it has this new feature in there. So this is sort of this is the workflow that I'd like to propose us using. We'll see how it works. I think so far I like how it works because we found a couple of issues already in this way, so it makes sense. So I've been talking about branching a little bit, and so been talking about branching. When to branch? Always. You know, if you're going to work on something new, you shouldn't be working on the master. The master is something that you use to demo. If somebody comes by tomorrow into your office and says, "Hey, can you give me a big demo of what Medici is?" You can switch back to the master branch and start it up, and it will work. And so you don't have to worry about your half-broken feature sitting there and not allowing you to do a demo. Other things are nice about branches is that when I was before working on OSPN, where branching is hard, I often worked on 2 or 3 different features at the same time, and I couldn't check in the feature unless all 3 features were fixed. Right? Because I couldn't check in, I couldn't easily pick and choose saying, oh, this file, these 3 lines belong to this feature, and these 3 lines belong to this feature. I had to make sure all 3 features were done before I could check that file in. And this gets really important if we start talking about bug fixes. If Kenton comes to your office tomorrow and says, you know, I found this bug, please can you fix it? And you're in the middle of implementing a feature. The nice thing with branches is it allows you to quickly store your code, do a commit, who cares, it's cheap, do a commit, switch to a new branch, fix the code to that new branch, push that branch out. And then you switch back to your original branch and just keep going. It's sort of just like a quick, you know, store your code in a little locker, fix it, take your code out, and keep working. It makes it, again, nicely compartmentalized so that you can focus on what you're trying to accomplish, when you're task you're trying to accomplish. So branching, you know, use it. I didn't believe it before we started using it in Medici, and now I just, you know, I'm working, I make a branch. First thing I do when I start working on something, I make a branch. It's made my life a lot easier. Tagging is, so branch is something where you take, it's like a tree, you branch off from a particular point, and you keep developing on that point forward. So you keep adding new commits to it. A tag, on the other hand, is you say, I'm tagging this point in time. And say, okay, this point in my commit history, I'm tagging it. Maybe this is the code that I gave to Kent for a demo that he was going to do. It's not an official release yet, but I tag it so that if somebody says, hey, I saw the demo we did, I can go back to that particular tag. And they're cheap. It's all it does in Git is literally store this commit message is this tag. It takes up like a couple of bytes. That's it. So you use them a lot. You know, if you gave your code to somebody, tag it so you can later go back to that particular point in time and see what you gave them. Well, branching is a little bit more. It has a little bit more extra weight to it. And like Luigi says, you have a stable piece of code you want ready for demos, tag it. Later on, you can check it out, then you can show it. You get on with the next feature, tag it, move on. So that way you can easily go back in time, find specific points in time periods, and you don't have to remember these ugly hash sums that get used. I spoke a little bit about this already. You clone, I put them in here so it makes it easier if we get the slides out to people so you can really look at them. Cloning a repository, git clone, you give the URL, and like SVN, another comment, you can give it the second argument, which is the name of the repository. So it doesn't need to be, if you clone Medici, you can call it the second Medici. And now you have also 2 Git repositories of Medici if you want. Fetch, get the changes from the remote. Merge, I will go a little bit more about that, but basically allows you to merge changes that are done on the remote or in other branches into this particular branch. So for instance, if you've been working on a feature and you want to have your changes now finally go into the master and push them out, you can just do a git merge with the branch name, and it will merge the changes from that branch into the master, and you can push them. Fetch and merge together at the same time, something we do all the time, git pull. As I said, branches are cheap and quick, use them often, you know. Try to branch from the master. Always when you create a new, I'd like to say always when you create a new branch first. Go first check out the master again and then branch. And the reason for this is if you push your changes for a particular branch out for people to use, it will basically have all the changes from the other branch there as well. So if you have, you create a branch with where you fix issue number 1, and you have like 5 files you change, and then you switch to, you create a new branch, so you should start working on issue number 2. When you push in the issue number 2 branch, it will contain all the changes you've done for issue number 1 as well. And so it makes it hard for people later to say, well, issue 1 is not completely finished yet, because there's still some things I want you to fix. Issue 2 is ready, but I cannot accept issue 2 yet because there are changes that are from issue 1 in there. So that's why I said if you can, just do a git checkout master, make sure that the master is up to date, and then branch from the master. So that your branches always start at the master when you start working on features. Now, sometimes, this is why it's not always, sometimes you're going to have to depend on the change you were making in the previous feature. Yes, branch from that point forward. Or sometimes you're wanting to do something completely crazy. You say, you know what, I'm going to branch here quickly so I can work in parallel on something else, but I'm going to try this crazy feature, crazy thing that I think might actually helpful as well. Yes, branch from that, branch from the branch. But in general, I think branching from the master is better. Git checkout -b with a branch name is nice. It's again a little shortcut, makes your life easier. It will actually create the branch and check out that branch. Instead of doing 2 commands, you only have to do 1. Renaming a branch, you made a typo, sort of embarrassing sometimes. You can rename your branch name so that the typo is no longer visible. If you want to push the branch to the origin or to the remote side, you can use the git push origin with the branch name. You can delete the branch, or you can actually delete the branch on the remote side as well. So once you're done with your feature, people have integrated them into the master. And at that point, you can just delete the branch and delete the branch on the remote side. Because they're not really necessary anymore because all the commits have been merged into the master already. And some other things. So how do you create tags? How do you push your tags out? The git log with the graph is sort of interesting. It gives you sort of an ASCII art piece to show you how all the branches and all the lines and all the merges happen and how everything comes back together again. Back to Eclipse, because we like it. It actually makes Git a lot easier. you can, once you clone in Eclipse, when you say you go to the Git perspective, you can say clone repository. You just give it the URL and it will fetch it for you, put it there. The next thing that's sort of nice is you can just right click on it, say import projects. If there's Eclipse projects inside the Git repository, it will find them and check them out. It will put them in your workspace. So check in the project files with in your Git repository so other people can easily get them and have their project set up for you. Makes it easier for people to get up and running. All the operations you need are under the team menu in Eclipse: fetch, pull, merge, commit, push. There's some nice features you can do. Branches in Eclipse branches in Git are not connected to a remote point. So they often are, you branch, and at that point they're no longer connected to a particular branch in the remote site until you push them out to the remote site. So if you branch from the master and somebody makes any changes to the master, you will not get them in your branch unless you do explicit rebase or merge. Eclipse allows you to basically, when you create a new branch, select an option that when you do a pull, it will either merge or rebase or do nothing from a particular point where you started from. So it's actually makes it a little easier for you. If you click on a Git repository and you say show history, it will actually show you the 3D graph as well. So it shows you all the commits that are there, as well as how all the branches were done and how they were merged. Let me finish off the Git section and then I'll take a break so people can go to the bathroom and get some water. As I said, Git is a distributed source code management system, which basically is going to mean eventually that there are going to be multiple commits done over the same time period. So if I do 3 commits and I push them, and Luigi during the same time period has done 3 commits as well, they're going to have to be merged. So if we look at the pictures on the right, the top picture, you can see there's a commit number 0, commit 1, 2, which shows you the order in which they were committed. And then at that point, somebody created an experimental branch, did a commit in there, C3, and in the master there was a commit done C4. At this point, these 2 branches have, the master and the experimental branch, have diverged. And so we need to somehow get these back together. The standard method that is done is merge. What this does is a 3-way merge. It does a 3-way merge between the branch and the most recent ancestor that these 2 branches have in common. So if we look at the graph here, it will try to do a 3-way merge between C3, C4, and C2. And so once that 3-way merge is done, it will create a new commit called C5, which contains all the changes that were done in C3 and C4 at the same time. So C5 will contain all the changes that were done, and will create a new commit called C5, and it will often, if you look at it, you will not have much choice, but it will just say merge between this and this. And so if you look at the history, you'll see all these merge commits that basically are this. Rebase is something that I like because it makes for clean history. It makes your history really look like a straightforward line. What it does is it will replay all your commits. So if we look again at the tree that we have, where we have C3 and C4, when I do a rebase, the first thing it will do is it will undo my C3 commit. It will just take the master and then reapply my commit to the master, and we call it C3 prime. At that point, if you look at it, and the rebase is finished, you resolve your conflicts, and you finish it, when you look at the history, you will see that it's a straight line. There will not be an extra commit done for C5. So it will make your history a lot cleaner. Do a search for rebase versus merge in Git on Google, and you will find a big flame war. It's sort of like the Emacs versus VI of these days. People say you should or should not do it. You should not rewrite history. You should keep the history as it is. That's merge. People say no, you should do rebase because it's easier for people to look at how things are happening and how things are committed. I tend to like the rebase because the history is easier to read. The one thing to really keep in mind is that if you do a rebase, it will change some of your commits. So if you have committed to a public repository C3, somebody might have branched from your point. If you do a rebase at that point, your C3 gets rewritten to C3.5. There, if you push that out to the main repository again, whoever cloned from the original one is sort of in a funky state. And I'm not sure what's going to happen. It will probably come knocking on your door. Now, it's not easy to do that. You actually need to force the push at that point. That's why in general I tend to say forcing a push is a bad thing. Because somebody might have at that point already made a branch from your particular. So keep that in mind when you do it. We can as well talk a little bit about John today. He was trying to do a merge or a rebase. Sitting down with him and talking a little bit about this made it easier. If you think about it from this picture, commit C3 is really a mini patch that is being applied to the code. If you think about it, each commit is like a mini patch. So if you have 5 or 6 commits, there are 5 or 6 little patches that are being applied to the code. What a rebase does is we'll start with the master and take each of your commits in sequence and apply them one after the other. So it will apply the first commit. If the first commit succeeds without any failures, it will do a new commit. Or if the first patch, basically, if the first patch succeeds, it will commit that first patch into the main branch. If the next one succeeds, etc. If it fails, you're sitting in a in-between state. You're not really on the master branch anymore. You're sitting in a between branch. If you do a git branch, you will actually see that. It will have a really funky name. What you need to do is you need to resolve the conflict. You do a git add or a git remove, depending on how you resolve the conflict. You do not use git commit. You just do git add or git remove. Then when you say git rebase continue, Eclipse has that in the menu, when line has git rebase continue, it will basically say, look to see whether or not you resolve all the conflicts. If you resolve all the conflicts, it will do the commit for you. If you have done the commit, like John did, it will basically be in a funky state again, and the only thing you can do is abort, it will roll the whole thing back again, and you can start over again. That's the nice thing about Git and source code control management systems. Really, unless you really mess up, you cannot break the repository. And especially in Git, it's nice. If you force it in there and you have removed everything, you totally messed it up, there's probably another 5 people that have the same copy of it, of the original repository, so we can restore it quickly. I'm going to take a break. I need some water. Build tools comes next. 5 minutes?
Yeah, let's first start, see if there are any questions or conversation that need to happen about those things, branches, the merging, all that.
Yeah.
Versus repository,
Mm-hmm.
we have discussed earlier, like we have to put it into our workspace and then check it out to the So do we need to branch it now, like branch from our local copy, and then whatever changes we apply, it will like to be pulled to our or pushed to our
So,
project area, then
yeah,
it will go
so,
in that direction. Like, what is the flow of information?
in the case of versus, so in the case of Medici, what we did with Luigi is we went in and sorry. Yes, we'll do some of the. I have a little bit of Git things that in the hands-on in a second. All right, a little bit. This is in response to the question that was on the screen. In the case of versus, so in the case of Medici, what we did is we basically gave everybody that is a Medici developer the ability to push into the Medici repository, except for the master branch. The master branch only me and Luigi have access to. So that way, if John checks out, if John wants to get repository, he knows the master has been looked after, and it's this blessed branch, blessed repository. We know, you know that that's going to be working correctly. In the case of versus, because there's 10 different repositories, I didn't feel like sitting there and clicking the 10 different buttons that's needed yet. We basically made it so that nobody can write to it, except for you, for Smoothie, Luigi, and me. But only those 3 people have write permissions to the versus repositories. What you can do there is instead is you can stash fork it, which basically means make a copy on the server side into your own personal home directory. Then you clone that copy to your local disk. So now you're an extra step away from the master, from the blessed version. Now Stash has a nice feature, which basically a little checkbox, and every commit that is done to the blessed one is automatically reflected into your copy.
Okay. So
Right? Although if not, there is an extra step that you need to do sometimes. But Stash has this nice feature where basically it can keep them in sync, or at least one way. When you do your work, you're basically working against the remote one that is in your personal space. Right? You're not working against the blessed repository. So you're working against the one that's in your personal space. No, you don't need to branch there. But it's too big. It's not a good thing to do. That goes into one of my next tasks. No, it's not a good thing to do because the same thing applies. You can work on the master as same as you can work on the master in any of the less repositories. But if you're working on 2 features, you can't. Right? You can't work on 2 features because you're working in the master. So again, it's best for you to branch off, work on each feature in a branch, push them to your own personal folder space of Stash, and then ask for a pull request from each of those.
Okay, so so if we are working on branch on our personal space, it will be same as when we create a pull request. It will be same as 2 branch in the main project, right?
Yeah.
Yeah, you're sharing the branches with the remote repository. So you start by creating your branch local, and then whenever you want, you can share that branch, push it up, right? The same way you push anything out. So you can start your branch local and then share it only when you want others to have access to it, including if you want to do a pull request, right? Because you have to put it up there to be able to say, okay, now I want you to integrate this in the master. Because the pull request is between 2 branches.
Yes.
Now, the reason to say you don't need to, but you should, is the master is your personal master.
Right.
Right? So if John wants from the blessed one, he will not get your changes. And so in that sense, yes, your master branch is another. But if you want to do a demo, you have nothing clean anymore. So you're best off trying to keep the master clean, right? Does that make sense?
And so when we have 2 branches for my own version of remote project, and when one of my branch change is ready now. Okay. So when I make a push, So I have to merge it into my personal or
You push it into your personal one.
Mhm.
You push it into your personal space, not the
Right.
master, but just into your personal space,
Right.
just like you would do otherwise.
Mhm.
And then you can issue a pull request for your personal space into the master that you originally forked.
You're pushing the branch.
You're pushing the branch into your
Yeah.
personal space,
Mhm.
and then you issue a pull request from the branch in your personal space
Okay.
into the master in the official space.
So until that pull is done, it will not be added to my personal.
And it will be in your personal space.
But as a branch, but it will not be in the master of
Well,
my personal.
you can do that yourself. Right? It's your personal space. Right? You can do whatever you want there. So if you say I'm comfortable with it, I'm going to merge it.
Uh-huh.
But the nice thing about the pull request, this goes back to way in the beginning, is it's a collaborative effort. The pull request basically forces somebody else to look at your code and see any changes you made, and just it's the first set of eyes that looks at your code, like, or second set of eyes that looks at your code. Right? It's the other person that starts looking at it and says, yes, this makes sense. And if you had to say, if you've already merged it into your master, and I look at your code and I find an issue there, and you're going to have to later on resolve that conflict. Right? So you're best off just waiting. You have the branch. You can always, if you need to do a demo with that particular feature, you can always check out that branch and show it to people. Right?
And when Rob does the hand-on tutorial, we can talk about specific examples there that should help clarify the differences between the different use cases. Because I think we're talking about multiple things right now.
And also, like when we make a pull request, so whatever changes or commits we have done, it is only that thing gets
I'll
pulled,
show
or
you.
it is the whole
How
of
about we keep that question till later?
Yeah. Sure.
Well, the reason why is because I have a pull request I'd like to show you that Chris and I did. The pull request that John is actually sitting there, that I can just actually show you what the process is. He's waiting for me.
Okay.
And then we'll show you a couple of other things, and I'll let you play with it as well. Yes.
Yes. That's a good point. Yeah.
No, I will look at your code, and again, I'll show you why that's important.
Because I mean,
The compiling.
small changes in
I'll-
different files. Would you have to code
Yes. In theory, we should.
Actually, we
them? You really should, yeah.
yes, and we actually did it.
We're doing. Right? So the thing is,
Remember what we said at the beginning, it's a social kind of effort, right? What we're trying to do is put in place a system that reinforces that. But this is one of the things that we're putting in place.
Right now, for example, I'm finishing something
Right.
and starting to start something else.
Right.
So will somebody actually have time to look at it?
you need to start a new branch.
Somebody will look at it. If they don't, it's their problem. If they just merge it with the master, it's their decision. But that forces them to take a look at it. If they don't, that's not your problem. You put it out there and somebody else, said yes.
And also it starts to, when we actually do this as a practice, I start to getting a little bit of pressure that I need to make more detail about each issues I'm making. So, because right now we try to also marry the stashes and pull requests with the Jira issue. And if you create a Jira issue really broad, like fix this problem, it's really not helping someone. So if you make it then more detailed, like the issues there, and you can work on it with that. And then later on, somebody actually review the code is much easier too.
And the people that have the ability of merging with the master, that are gonna review the code, right? Well, two things. One is, I don't know how much you know it, but he's gonna show it. But you can decide who gets to review your code. So if you want somebody specific to take a look at it, you can put their name on it. But in general, the people that can merge with the masters are the people that know the entire system, so that they can make sure that whatever goes in, right, doesn't, it's in line with everything else. So it's to their benefit that they actually look at what they're saying yes on. If they don't, then they're, making more work for themselves later on. And that's what we're trying to avoid. Is we're trying to avoid situations where we have a master as a code checked in, and only one person who developed. That code is in the in the master, and then all of a sudden down the road you go, oh no, that's wrong. Well, at least you have multiple eyes on that, so it might still be wrong, but yeah.
And then the other thing is, right, a little bit, John is touching on it, a little bit what I'm saying, is when you work on a feature, you create a branch. So when you're done with that feature, that branch is done. You basically push that branch out and people start doing on the view on that branch. If you work on the next feature, you start a new branch. That way, a commit should not become too big. Right? Either the problem lies in you're trying to do 7 things in one branch, which we're trying to avoid, and this allows you to do easily with the switching of branches, so you should be able not to have to do that. Or the issue is too broadly defined, at which point you're better off taking the issue, making a couple of smaller subtasks, and say, here's 3 subtasks that need to be accomplished first before this bigger issue can be closed. And then now you've basically minimized the number of pieces of code. It's easy for people to look at it. Your pull request is going to be approved quicker as well. Right? It's to your benefit as well to make the pull request not be 1,000 files with 20,000 lines of code. Because it's going to sit there and I'm going to whenever I have a week free, I'm going to look at it, which is never. So basically try to make sure that your commits are small, not too small, you have to solve the problem, but focused on what you're trying to do, not try to push in an extra 3 little things that you did at the same time. Make little Jira tasks for them.
So even within 2 days, I split some of the issues into 2.
Now, your second part of the question, will we compile it? No, and that's what a build is going to break. So this goes a little bit on the question that Ina asked. When code has been committed, do we just look at it or do we try and compile it? And this goes back to the beginning as well of documentation and how to make things easy. Build tools. If somebody comes new on your project and you give them a list of 27 steps they have to take to get the project to compile, it's not an easy way to get started with the project. And things will not work. Sometimes people document them in READMEs, but they forget to say, oh, by the way, you need to install these 37 packages first before you compile it, or you need to download this library from here first before you can work. Build tools can take some of these away for you, or at least make the steps that are needed to get things to compile easier. The TIFF codes that we have here, there's 3 libraries that it depends on. If you go and check it out, initially you sort of assumed that those libraries were compiled and sitting somewhere. Now, with the build tools, with the correct make files, those libraries are first built, if they're not have been built already. And then when you build the final binaries, it knows where the libraries are and it will use the libraries. So it makes it, all you have to say is when you want to compile this, type make versus go into this folder, type make here, copy the binary to here, then go to this folder, build the make, build it, copy the binary here. Yeah, it makes it a little bit easier for people. So make and make files are used for C, C++, Maven, which and Ant are used for Java, and Scala uses SPT, Scala board. These are some of the things that I know. Other languages probably have their own build tools as well. I'll go a little bit into Maven later because I think it's something that we should be using. We haven't used it much in our previous project. I think we should start be looking at for these like projects because a lot of the problems that people have finding the right libraries will be solved using. The other reason to have these build tools is, and this goes to Ina's question, is continuous integration tests. Continuous integration is where we have a build system that will build the moment you do push or commit. It will see that there is a change to the repository. It will take the changes and try to build it. It will use these build tools to actually build it for you. So these build tools are needed to be able to do this continuous integration, but also, like I said before, it basically becomes part of your documentation. And it will catch errors. You can now do a commit, and I say if you do commit to a repository you're responsible for, wait 15 minutes to make sure everything compiles correctly. If you get the yes or no question back, if you get the yes, you can go home. If you get the no, fix what you did wrong. It might be as simple as, oh, I forgot to check in this extra file. I made a new file, I forgot to do a git add, it didn't get committed. Yes, it works fine on my local machine because I have the file sitting locally on disk, but the remote machine doesn't see that file, and so it doesn't compile. So, Maven. Maven is a Java tool. It uses a font.xml file, and it describes how to build, and it also describes the dependencies that are needed to build. And it's the cool thing is that I no longer need to tell you, oh, to be able to compile this particular package, you need the following 6 libraries. This library needs to be version 4.0. This library needs to be 6.0. This needs to be the latest snapshot that's available. This needs to be a version that's 3 years old. I specify, I document all this inside this Maven file. And now when basically somebody else gets it, they know immediately what is in the file. Actually, on top of that, you don't even need to provide the jar files anymore because they get downloaded automatically for you and be ready. Other things that Maven files can do is they can zip them up, they can create jar files, WAR files, zip files for you to distribute to other people. Which was mentioning or talking about, it will allow you to push the results of your build into a central repository. I make a change to a central library that we have. I commit it, it gets built. The build tool will automatically push it into our central repository. Smoothie starts working on something else. She say, for instance, the verses. I make a change to the verses score, it gets pushed out. She's working on the audio extractor, or audio code for verses. When she types in Maven build, it will go out and says, oh, there's a newer version of the core. I'll download it and have it ready for her. So she's building against the latest code. Unless she explicitly says, I can only work against this particular version. And this becomes really powerful, right? You can say, I am only building against version 1.0, not version 1.1. Because there might be an upgrade that they did to the API that made it incompatible. The other reason is, and I'll show you an example for this, you don't need to include libraries anymore. Maven will take care for you for downloading the libraries to your local machine instead of checking those into source control. It's kind of silly to download a jar file, stick it into your folders, and push it into a central repository. Right? Because they're binary files, they come from somewhere else. Why should you do that? And I'll show you why. So for instance, the original Medici, the GWT web app that we had, it holds the source code in this Git repository. There is 6,300 files in there. 599 of those files are jar files. There's about 600 jar files in the repository. The repository is 600 megabytes, which is a significant chunk for somebody to actually download the very first time. Out of that, more than half is just jar files. So if we use Maven for this project, we could shrink very quickly the repository in half, which is a significant achievement to very quickly accomplish. If you look, there's a WAR files checked in, that's another 100 megabytes almost. And the 1/20th of the total repository is just a Java source code, which is really what we care about having it sitting there. Most people just have the other style sheets as well. But if you look at it, the significant chunk of the space that's taken up by our repository is taken up by unnecessary files. Either are results of a build or are just artifacts that we needed to download so that we can build it. So they help. Writing good code. So that's a little bit, so those are the software development tools that I want to talk about. So I think, great questions. I'm going to talk, huh? I will go with the numbers. So I think any questions about Maven and things like that. The show and tell comes later. We'll have a little bit of Maven in there so you get familiar with it and see what it looks like. Writing good code. XKCD. Most programmers are probably familiar with this. Here's a wonderful flowchart that he came up with. This flowchart shows you how to write good code. Basically, you start the project, do things right, do them fast. And do it fast, you write your code fast. Does it work yet? Yes or no? If it doesn't work, you keep hacking away at it. If it works, if you write fast code, it's usually not the prettiest and good code. It's just a hack usually. So you start it, allow to start up again. If you do things correct, it will take a while. You do it correctly, you do it perfectly. It takes a while for you to get it going. Eventually, by the time that you're done with it, the requirements have changed. You throw it out, you start up again. Really, if you look at it, it's really hard. There is no magic stick to use to write good code. What I'm going to present to you are some little pieces that might make it easier to write good code. That might make it easier for others to help you with good code. So, writing good code, there's 4 things that are needed there. Documentation. Most important thing for writing good code is documentation. Java docs and a function. Explain what a function does. Eclipse is powerful in this sense. If you write your Java docs for a function, when somebody else uses that function or you use that function later in your own code, it will show you the Java doc and give you a hint about what are the arguments that it takes. What is return value? What does this function actually really do? And if you write that down, the next time you're using that in your own code, hover the mouse over it and it will show you in yellow the little pop-up saying, this is what the function does. You know, it makes your own life easier, it makes life more comments. Really, I think one of the best things you can do is go back and look at your code you wrote a year ago and try to understand what you did. I'm talking with some of the professors, and I think one of the assignments they really should give them to the students in the classes is, here's the code. So write your assignment. All right, everybody, hand your code to somebody else, look at it. Try to understand what you're doing. And looking at somebody else's code makes you realize you need to call it your code to document your code, probably as well. Manuals, I talked about it. Comments, Java doc is not enough. It doesn't give you the big overview picture of what it does. Coding styles help understanding your code, help other people to understand your code. I can not use any tabs or any spaces, and it makes it horrific to read code. Writing actually probably knows. We showed them some codes where there was some method tabs missing and things like that. Even wrongly indented code makes it hard to read code and actually probably results in errors. Python is an interesting example of a language, programming language. Python enforces correct indentation. If you don't indent the line, it will assume that the line is ended. There are no curly braces for batching clocks. It's just the tabs are the curly braces. Logging and exceptions, I'll go a little bit over that, what to do there. Testing. Testing is important. Well, the anecdotes today, there's different tests, unit testing, integration testing, regression testing, user testing, I'll touch all of those. The final one is really important as well, is bug reporting and bug fixing. It's hard to write good bugs. Well, it's not hard to write good bugs, it's easy. It's hard to write good bug reports. It's hard to write a report that basically, if I write a good report, it should be easy for Ashwini to fix one, because she has everything she needs to fix it. If I write a simple report saying it doesn't work, she's going to ignore my bug report. that even if I say it crashes and I don't know what I did, but it crashes and here's the stack trace, it's probably still not enough for her to fix it. I'll go a little bit there as well. So, minimum requirements if you start a new project. README, general information and installation instructions. You know, how to install it, what does it do, some general information about the project. Stick it in the root folder of your repository. Slash GitHub, a lot of these places will actually show that README to the user when they go to the repository, and allows you to basically show them what your project is. This is the web page that they will be looking at to understand what your code does, what your project does. So this is important. License, stick a license in there. I like the NCSA license because it's a very open license, it's a very free license, like the free ISDA license. I tend to stay away from the GPL license, just because of the nature of it. If anything, I like the lesser GPL license. But the NCSA license is really free. Basically, the license says you can do whatever you want with it, as long as you give credit to us, and that's it. And we're not liable. I'm not liable, yes. That's basically the license. And the other nice thing about that is that the license is literally 4 paragraphs, I believe, versus the GPL license, which is 3 or 4 pages. Right? So the NCSA license, something you can easily read. The GPL license, it takes a long time, but most people are. Although I don't think most people still know exactly what it means. Comments. I touched on this. Our projects are getting bigger. You are no longer the only person working on a project. Most of us are working on 2 or 3 projects. Most projects have 2 or 3 people working on it. Comments are your way of interacting through the source code with each other. This is how you explain what the code does. Now, like I said, even if you are the only person working on this, will you understand what your code does next year? And this is where you need to start thinking about. If I write this piece of code a year from now, if I have to go back, will I understand what it does? Right, Leanne?
No.
Leanne and I had a discussion about this at one point. It sounds silly because you know exactly what you're doing today, but a year from now you've worked on 6 other projects, and then you don't understand anymore what you did. Comments and documentation are a requirement for good. Without documentation and comments, sorry, code is a hack. You're sitting on the right side of the XKCD comic already. The other thing too, other thing is, and I do the same thing because sometimes you get in the mood and you just keep going away. But try not to wait till the end of the project to start commenting and documenting, because it's too late. You probably already lost some of the ideas of why you did certain things certain ways. Especially if you work on a larger project, and if you, like we do talk about earlier on the Bazaar model, where we start sharing the code earlier on in the project, start trying to document it early on so that other people can look at your code, know what you're trying to do, and look at your code and says, I don't think it does exactly what you think it does. Right? That's where the commenting comes in. JavaDoc, RoxyGen, ScalaDoc, etc. Here's the link to the ScalaDoc, how they recommend you writing ScalaDoc. If you document functions, give it using JavaDoc, ScalaDoc, give it a short title. And it's usually, if somebody looks at the JavaDoc and ScalaDoc, it's sitting at the top, where they basically said function X does Y, function B does this, etc. Then the longer description is once they go to that specific function, the longer description is shown there. That gives you a little bit more chance to go to details what it does, if they're specific on it. List the parameters it takes. Are there any specific values you expect for them? What is the return value and author? Take credit for what you do. That way, if there's a particular question that I have about a function, I also know who did it. I know something. As I said, these JavaDocs and ScalaDocs and everything else, Eclipse will use them to help you doing the project. help. It's for yourself as well. Document algorithms, not basic code. Try not to use the following comment, Knuckles magic, not sure what it does. You will see it in most projects. There will be a point in the whole project flow where something happens and somebody wrote it at that point and people don't exactly know what it does anymore, but if people try to change it, the application doesn't work. If you write this comment, you need to rethink what you're doing. This is where you rewrite things. Right? A good programmer knows what to rewrite. This is probably a point you should say, maybe this should not be magic. Maybe I should know what really is happening. Things to keep in mind, especially in open source projects. Other people will read your comments, including your future employer. Jamie Zawazinski, who worked on Netscape, has a beautiful web page where he lists all these swear words that are in the Netscape source code. And you can just find them. It's out there. People find them, right? If you put a swear word in your source code, if you bash one of your code workers, somebody will find it. There's lots of anecdotes that you can find on the line where people write in foreign languages and bash their code workers in the source code. Google Translate those wonders. Don't. Good things to do is put a comment on the algorithm. Following code will find all primes and multiply them. At high level, this is what the following piece of code does. Add 1 to I, not really useful. I can see that, probably, especially if the code underneath it says I plus plus. It's just a waste of people's time to look at that particular code. If you know something is not ready, comment it. In Cyber Integrator, we have a bunch of REST endpoints that are not implemented. We didn't initially add to-dos and fix me to it. So there's these endpoints that basically look like they're working. And if you quickly look at the source code, nothing in it helps you saying that things are not there. Again, Eclipse helps you. If you put to-do there, the Eclipse will mark it off with a little blue check mark. Now you can quickly look at the source code. We went through and added the to-do statements there. You can look and say, oh, there's a bunch of blue marks. Let's see what they are. Oh, yes, all these endpoints are not in. Good, I can look at that. There's a view in Eclipse even that goes through your source code, your project, and lists at the bottom all the tasks and all the to-do tasks that you have marked off in your source code. So you can quickly double-click on the task, on the to-do, and jump to the right place in the source code.
Stash or
Stash, I added a plugin for Stash to actually show you all the to-dos as well.
I saw that if you click on it, create the Jira issue. Yeah. Very nice.
Other thing is, if you know you're responsible later on fixing it, just mark it off. Right? Cyber Integrator, we started doing to-do arcade, which means that this is my to-do. I know I need to do it later. John needs this particular piece done now. He knows who to talk to because it's my item. I said, just a high item for you. Documentation. As I said before many times, function documentation is not the end. You can document all the functions, you can document all the classes, you can document packages. If people don't understand why you write a specific thing or the whole library, you might as well not written it because people will not use it. And if they don't know what the high level use of that library is, they'll probably skip it. Add documentation to packages and modules. In Java, if you create in each package, the package of HTML, it will be compiled to Java doc. Here you can do higher level documentation. What is this package for? What are the pieces of code? Why do you group all these classes together in a single package? It gives you a good place to start putting a little bit of example of the same classes. At the top of the class, you can put a piece of documentation. In there, you can say, this is what this class is trying to do. This is what is being used. This is how you use it. And here's a piece of example code. If you look at the swing classes, for instance, their top Java doc is 1 or 2 HTML pages long. And it gives you extreme complex examples, but it gives you some simple examples on there. And some of them actually point you to a tutorial to get more information. That is what I talked about, the documentation and the manuals. They have these tutorials where they explain you how to use it. It's a higher level explanation of plants. Manuals, usually manual writing is boring. What does the software do? The bottom here is some interesting quotes that I found on the Jira, on the Atlassian website. This is the Gantt chart plugin. Basically, the comment says needs documentation desperately, and it's very difficult to use. And the author's comment was, I have decided to focus on complete support requests and I've just embedded basic documentation. People are hammering that particular plugin because they don't even understand what it does. They will ignore this plugin. If this happens to our source code, this happens to our project, if we don't document reasonably well for people to understand what it does and how to use it, you pretty much have one chance to win somebody over to a project. If they don't even understand what it does from the beginning, they're going to come in with a very negative attitude, if at all. Right, so your documentation should get them excited about using your product. Code styles, as I said before, Python enforces good indentation. If you don't indent Python correctly, it will actually not work. So you have no choice with Python. A lot of other projects have a semi-standard way of coding. Java uses, was it currently in Richie, SBT0 or something like that style. Scala has its own style. Web pages have a style that they use. Eclipse, again, has formatters. And they're actually really powerful. You can take the piece of code and tell it to format it, and it will apply the formatting rules to it like you want it. So in Cyber Integrator, before we actually really started implementing things, we came up with a coding style. And every project that we have in the Cyber Integrator, we store those coding styles with the project itself. So if you check out Cyber Integrator and you load it into Eclipse, you're forced by Eclipse to use our coding styles. So without you doing anything, you're already having the parentheses at the right place, the curly braces at the right place. You have the right tabs, you have spaces there instead of tab guides, etc. All that is taken care of for you by the parameters. It can go as far as basically having Eclipse set up so that every time you hit save, it will reformat all your code. That's a little bit too far on the extreme, but at least enforces people to not check in badly formatted codes, because every time you do something, it's formatted.
So we actually have predefined ones, right?
We have for Cyber Integrator, we have a predefined. Managed, I don't think we do. It's just up to the person that is in charge of the project. So Luigi has some sort of, Kenta has its own polyglot. And the thing to do is if you come new on a project, is probably talk to whoever is in charge of the project and say, are there specific styles you would like to see happening for this particular project?
The reason I'm asking is that because of style changes, when you commit it to the source code control system, it basically shows you that everything is different. That's not actually. Your style changes, code is the same. But that's sometimes painful.
It's sometimes painful, but that's also you should be formatting your code.
No, what I'm saying is that if I'm formatting to this project, later on this flow using the Medici. And so by touching the Medici project, touch that code.
Well, so in Cyber Integrator, so the Eclipse is set up such a way that
you can switch it, yes.
You can have per project formatting rules. And so I have set most of the projects up to be per project. So when you check out a particular Cyber Integrator, open up a project, Eclipse will say, I need to use the formatting rules for this project. And so even though you have separate formatting rules that you use in general, the way it's set up, it will force you to use, or Eclipse will automatically switch to formatting rules for that particular project. Yes, if somebody applies different formatting rules, yes,
in my head with contribution path.
This is where code reviews comes in. You say, why did you reformat it? Was it really necessary? Please go back, take your changes, and keep the formatting rules according to what was specified. In the end, it doesn't matter how code is formatted. What does matter is be consistent. Don't use the first half of your code 4 spaces, the second half use 1 space, the third half put your braces one place, the second half put your braces somewhere else. You know, try to be consistent because it makes it easier for people to look at your code, makes people want to look over your code, makes people want to help you find your bugs and find your bugs easy. So if I had to learn, we didn't have any software and any coding styles. Undergraduates come in, they basically use different coding styles. In the end, it makes it really hard sometimes to read code. But like I said, the most important thing for me is just be consistent on the project. Logging. This is one of my sort of pet peeves. Don't use system out or error, please, when you're checking your code. Don't use exception.print stack trace. And the reason for that is that if your code is going to run as a service or on a server somewhere, those things might not end up being captured. They might end up being sitting somewhere randomly in a separate file. And so debugging later on when the server crashes is really hard. There is, I think, 2 really good Java logging facade packages. There's one called Commons Logging, which is an Apache project, and one is SLF4J. I have the impression that SLF4J is mostly more popular one these days. What they do is they have, it's a very thin package. It's a couple of 20, 30 kilobyte big jar file you put in your project. And what it does is it allows you to say something like log.error. It will write into a specific place, send it out, file, you can configure it later using the one more complex logging packages, exactly when the error happened, where the error happened, which file, which line the error happened, messages, if you have exceptions, the other thing that it allows you to do is it allows you to have different levels. I listed here at the bottom, and I think they're severe as well. Trace, debug, info, warn, error, severe. Usually trace used for insane amounts of debugging information, entering a function, leaving a function, so you put a trace usually. So you know I entered this function, I left this function. I entered this loop, I left this loop. So you know exactly where in the code you are. Debug is useful for the developer. What is the value of this variable? Info is something that the end user might be interested in. This is version X of the software. Warning means something didn't go like I expected it to go, but I think I solved the problem. But be aware. Error means something didn't go the way it should go. I don't know what happened. I don't know how to resolve it. Be aware that the results you're getting is probably not correct. And then the severe, which usually I tend to keep, and most people tend to keep for like, I'm about to crash. Here's the last thing I can tell you. And I'm going to die now. Right, so that's what severe is. The cool thing about log4j and the JDK logger, which is logging as log4j will work with, is it allows you, using a very simple text file when you launch your application, to switch between the levels. So when you're working in debugging mode, or when you're working yourself, development mode, you can set it to debug. You get lots of information, you can see exactly what is happening, where it's at, what all the variables are as it goes through your algorithms. But when you go into production mode, you might not need this. You don't need this debugging mode. You might just switch it to debug. Instead of having to recompile your whole code base, all you do is you go into this one file, change it from debug to info. Also, nice and quiet, there's only a couple of messages that you see. You deploy it, it's sitting at the site, they're happily running with it, something goes wrong. Instead of them having to try and tell you what's going wrong, what you can do is you can say, hey, can you reproduce it? Can you go to this file, switch to debug? They run it, you write the debug messages to the log file, you ask them to send the log file to you. Also, you have a very detailed what is happening in the algorithm. Again, and it's going to help you. You can look at the variables and say, hey, this variable is null here. I didn't expect. Why is that? Let's look a little bit up. Okay, this is what's happening. Can you send me your example data set for this particular point? And it makes your life easier later on to find issues. And you don't have to send it, oh, here's the binary with the debug information. They can just do it quickly, switch it on, etc. So yes, please try and use logging. And the exercise will go into that, how to do that. Exceptions. When catching an exception, log it, even if you rethrow it. Please, 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 please. Print out the exceptions. I spent days trying to figure out why something didn't work with Tupelo. Because they caught an exception and tried a second case statement. And the exception, really the first case statement, was really where it went wrong. And they never printed it out. It took me, I had to step through their code completely to get that one particular point where they caught an exception and didn't log it. Had they printed it out with the debug statement, I would have been able to see it. I would say, okay, this particular thing wasn't set up correctly. It would have saved me days of debugging. So if you catch an exception, try to just log debug it. So that way, later on, we can easily turn it off when we don't need it anymore. And the logging packages even allow you to turn off specific function at a function level, what level they should be able to log it at. But later on, we can turn it on if we need it. And you might think, I'll rethrow it, and so somebody else will take care of printing it out. No, they might not. They might catch it and just ignore it. Other ones, so this one here, don't catch an exception and don't do anything with it. Other thing to keep in mind is, catching an exception like this, just a generic exception, try to be more specific. If you know there's going to be an IO exception, you catch an IO exception. I hate runtime exceptions with passion because codes will throw a runtime exception. If you don't know it's going to throw a runtime exception, and you don't have to catch it because they're runtime exceptions, and they will trickle up all the way through your source code, all the way through your code, all the way through the name, and break your program. Those that you didn't expect to happen. A number format exception is a wonderful example. Is that right? Did you remember? The number format exception is a runtime exception. If you do a parse a string to an integer, it will potentially throw a number format exception. Because basically, if you say parse hello into an integer, it will throw a number format exception. It's not listed as an exception that potentially is thrown. You will not catch it. It will trigger itself all the way up. And before you know it, your code breaks because somebody typed in hello instead of number. When logging, if you log something, most of these packages allow you to add the exception to it. So if I say log error could not open file, comma E. What will happen is it will print a message saying could not open file and list the exception in it. Sometimes the exception will say that the file was read-only or that the file didn't exist or the network was down. And it gives you a little bit more information that you might need to actually know something, why it didn't work right. Testing. Software testing can be stated as the process of validating and verifying that the computer program application product meets the requirements, works as expected, can be implemented, and satisfy the needs of stakeholders. So these are pretty much all the levels of testing that we want to do. But testing makes sure that is important because it makes sure that what you deliver to somebody actually does what you think it does. Right? Does it do what expected to do? Does it do what the people that want my code to do? Want it to do does it do that? However that goes sentence. When to test? Now, so start when you start writing code, start writing little tests to go with it. If you write a piece of code, think about your code, and write little tests to make sure that your code actually does what it's supposed to do. Things that I find get overlooked too often is use cases. Use cases are what does the user want, the end user want, what does the stakeholder want, what's the person you're working for, why do they want this piece of code to do something? That will lead you to write test cases. Does my code actually do what they want it to do? You write a test case, and also you have documentation because you have a use case, you have a test case. Both of those are part of the documentation. Other things are when we do builds, these test cases can be automatically run. Here's an example. Last night, John was writing a piece of code. He committed it. It compiled fine. I had written a test in the test build. John went through his code and basically said, oops. There's a variable that I didn't do something that I
You can show them the comment.
So there's something, he forgot to do something. The test caught it. Basically made him go back and fix his code. This is where the continuous integration comes. We check something in, the build happens, test the build. Using these test cases, it says yes or no, it works. If you do any refactoring, tests will make sure that your refactoring was done. If I take a piece of code out and move it somewhere else, if my test all of a sudden fails, then my refactoring was not right. Other thing is, if you look at your code and you're going to write a test case, a correct way of doing it would be write your test case first. What does it need to do? And then write your code. I don't work. I write my code and then I start writing my test case to make sure it works. The thing to keep in mind, though, is that you shouldn't write your test case with how is my code going to pass the test. You should really write how is my code going to break the test. And it's a subtle little difference, but it's important. You should write your test to basically make your code fail, not make your code succeed. It's easy to make your code succeed. And if I have two numbers and I need to add them together, it's easy to make the test case to say, can I add 1 plus 1? Yes, it works. See, ta-da, my code works. Well, what if I pass it 1.5 plus 1.5? Oh, well, my code was affecting integers. Right? So it's easy to write a test that basically I know beforehand it's going to pass. It's a little hard. It's harder to write a test that this will try to break your code. And we're not sure why this happened. All right. So think of your test cases that don't think of test cases that pass, think of test cases that break your code. Types of testing, unit tests, small tests of code, functions, the short tests, there are many of them. The total code base, I think, has about 2,000 or 5,000 tests that they run on every build to make sure it works. They have like 5,000 tests that they run. So there's a lot of tests that they have in their source code. But they're very short. The problem is unit tests will test small pieces. They will not test them. So that's where integration tests, big integration tests. Integration tests are bigger tests. They take a larger chunk of your code, lots of little functions, lots of little modules, and test them together as a bigger coherence. Integration tests can be combined together to make bigger integration tests, eventually to make complete testing of your whole software. Regression tests are actually really important. If you have a bug, and this is where the good bug reporting comes in, you should write a test to show that you have a bug, and then fix your bug. That way, later on, if there's any refactoring done or any other new code bases are done, you know that later on that bug will not reappear because you now have a test case for it. User testing, the end of the day, we're working for somebody. If we have something, they should be happy. So MSc project, in the end, if the guys that doctors don't like it, the scientists don't like it, we need to go figure out what is it that they don't like, how can we help them, how can we fix it. The other thing is, I also see when people are doing user testing is, oh, you should click on this button here to make it happen, or you should click here. You should give them a generic task. Here's some data, can you enter that? And see how they struggle with it. Why is it not working for them? Try to solve that problem. It's easy for us to say you need to click here, type your number here, and do this. But if we say, can you please enter this data into the database, and they don't know where to start, you know there's something wrong with at least with your interface. Bug reporting, as I said, it's important, it's hard. Include as much details as you can. Don't just say it doesn't work. What is the version of software you're using? This is where the tags come in handy. If I can say if I can give my code to Smoothie and say, here's my code, I tag that for Smoothie. Smoothie version 1. And she comes back and says it doesn't work, I'm using Smoothie version 1. I know exactly what she was using. I can go back to that and figure out. If it's a web-based, what browser are you using? Are you using IE 6, 7, 8, 9, 10, 11? Chrome, Firefox, Safari on mobile? What are you using? Help me. If you don't help me, I cannot fix it. Are you using Java? What version of Java? You have stack trace. This is where the debug logging comes in. Can you please turn on the log debug? Can you send me the logs for it? So I can look at that. Do you have an example data set you can share with us? Even if you need to send it to me private, do you have a data set where it always fits? Try to add some steps. I opened the application, I clicked on this button, I typed this in, I did this, and it broke. Here's 6 steps I did, and I can do these 6 steps every single time to make it fail. Bug fixing, if you get a bug report, write a simple test case first. This is where I really go to. You get a bug, try to write a test case that actually shows that the bug exists. Now I have a simple way for me to know that I fixed the bug. Fix the bug, say thank you to the person. Take the test case, especially in a version, especially in the security issue, I think, apply the same test case to every single branch, every single released version of your software, unreleased version of your software, and see whether or not that same bug appears. If it appears, you might be able to apply the same action. So that's good software. Good writing code. Questions? Fine. Software development, agile development. I think it's something that people have been start using more. Lightweight software development has been around. Lightweight development, 1957, AT&T, Bell Labs started using it, I think, to make switchboards, phone places already. Agile software development evolved in the mid-90s. When I was in school in the 90s, we learned the waterfall model. It's counter to the waterfall model. The waterfall model is very strict. Do this, then this, then this, then this, then this, and at the end you get a good product. In 2001, I can't read my notes, but in around 2001, about 17 people got together in Snowbird and came up with this, wrote this Agile manifesto. So we're uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value individuals and interactions over process and tools, working software over comprehensive documentation, which goes a little counter to what I talked before, customer collaboration over contract negotiation, and responding to change over following a plan. The values on the right are important. The values on the left, which I highlighted in red, are more important. So if there's this trade-off, if you're going to have to use this trade-off, try to satisfy the ones on the left first. Yeah? If you have a plan might change. something might come in that changes the plan. Don't stick with the plan. Let the plan go a little bit. And this is where agile development comes in. Don't let the plan go a little bit and try to solve this, go with the new direction that the plan needs to go to. And at the end, you're probably going to deliver a product that the user really wants to use versus a product that they thought they were going to use. And the product that they thought they might want to use is probably not what they really want to use. Because once they start seeing it, they start saying, oh, you know what? You can do that kind of stuff? Well, in that case, can you please go in this direction? Gotta be careful with it, but gotta follow. Scrum basically matches really nice with Agile. Key principle of Scrum is recognition that during a project, the customer can change their minds about what they want, what they need. You know? Especially if you have a 5-year project. We might start off with this is where we're going in 5 years, but as we're working, if people start using it, we might decide, you know, our end goal might need to be shifted over a little bit to actually meet.
We might.
We might, yes. So, might not, but we might. So,
we will.
We probably will. Things will change in software projects. People change, people might come in with new plans, better ways of doing certain things. How do you react to this? Will you stick with your original plan, or will you allow things to change to basically become better? From saying it that way, you probably realize that the better thing to do is have the changes to be incorporated. Some definitions that I think are important to know. Scrum talks about a product owner who is a single person, usually in the team, that's responsible for representing the interests of stakeholders. The Medicis, when we did the Medici things, Luigi was the product owner. And he is the one that sort of represents the needs of the people that are going to use Medici. He tries to make sure that what we're doing meets their needs. And there's the Scrum Master, which was Dave, who's responsible for this whole Scrum process. We make sure that we don't go too long, that we get things done. He oversees the whole thing. There's the development team, which I think in that case was, you were there as well, right? The Medici, what we did the Medici. Scrum one. So it was me, Smoothie, Sandeep, Luigi was there as well, so we're sort of the department. It's the group of people that's responsible for delivering the product. They're responsible for it. And then there's a sprint, the Medici sprint. We did a sprint for ISDA. It's time period. The Medici was very short, it was 2 days. Usually they're longer. ISDA one was a week. Where you try to pick up a certain set of tasks to try to accomplish them. And so the sprint is we have 1 to 4 weeks to get this done. It's at a time, say, we have 4 weeks from today to get all these tasks done. So we did our stand-up meeting last Monday. It's 15 minutes. Usually they're done once a day. We thought that was going to be a little bit too much, so we said let's do it once a week, maybe twice a week. Maybe we talk about it. What have you done since the last time we met? What are you planning on doing? Think about it, right? So last time we only really talked about what are you planning on doing. Maybe Friday we have a short one where we say what did you do? What did you accomplish? Are there any impediments or stumbling blocks? Are there any things you're stuck with right now? You just raise your hand. Say, this is what I'm stuck with. The trick is, and this is going to be hard for me, is that you shouldn't discuss at that point what the problem is and how to solve the problem. You just take a note saying, John is stuck on this particular thing. I know how to solve it. I keep the note sitting next to me. After the meeting is over, I'll talk to John. Often after a stand-up meeting, you have a second meeting, which is slightly longer, but we can just do it the hallways, where you talk to other people that have problems and try to help them solve. So that's where the discussions are. Sprint planning meetings. it's supposed to be 8-hour long. Good luck trying to find 8 hours for people. 2 times 4 hours. What are the tasks we're working on? So the tricky part is when you create a sprint, you really should limit the number of tasks that are in the sprint. You want to get in the sprint a set of tasks that you think are accomplishable. Often the task, so the way that Scrum works is you have points that are associated with a task or with an event, and you basically say, I have this many points I can work on based on the amount of time you have. So you have to pick and choose between your tasks. Say, these are the tasks I have points for. These are the tasks I have time for to accomplish. So in the case of the managing sprint, and I think for the Kissy sprint as well, we just overreached. We put too many things down for the short amount of time we had. So that's the planning meeting. Usually they say split it in 2. First part is you pick the task you're going to work on. The second half of the meeting is how you're going to accomplish those tasks. So the first task is a bigger meeting. The second task is just a developers meeting, development team meeting, where they sit down and say, let's look at the tasks we've chosen, how we accomplish these tasks. At the end of a cycle, at the end of a sprint, you're supposed to have 2 more meetings, 4 hours each. The first meeting is the sprint review meeting, which is basically a big meeting about what was done. Look at the whiteboard, look at the planning board, the tasks we had before, which ones got done. Let's talk about them. How do we do what we do? How we do with these tasks? Are we happy with them? Then there's a second meeting, which is the retrospective meeting, where you look at the sprint and says what worked and what didn't. Why didn't things work with the sprint? Why didn't we get all our tasks? And you look at it, you try to figure out how can we improve our sprint. So that the next time we have a better sprint. But this is sort of the agile part of it. It's trying to, every time you do something, try to improve your process, improve what you're trying to do. NCSA open source. I asked everybody to make sure they have an account on there. It's a server we have here inside NCSA. We have a full Atlassian stack on there, which is Confluence, Jira, Stash, Bamboo, Fisheye, and Crowd. We have the Nexus, Sonatype Nexus on there, which is made an artifact repository, and we have Jenkins, which is another build system. It's all of this one server. It's an i7, 16 gigs of memory, 1 terabyte of storage, of which 700 is free, 700 gigs is free, and it's continuously backed up using CrashFire. So it's nice system, and it works well. I don't know, for those people that were here when the Tresses people did their presentation, they realized that this is actually, it is a really sweet little stack that we have running here. I think somebody did the math at one point, it's like $20,000 or $30,000 software that was donated to the service. Confluence, the URL to it. See, everything is open source to NCSA.Illinois.edu / Confluence, Jira, Stash, Bamboo. Confluence is the wiki, good for documentation, how to install your software, who's working on this project, what are you working on, just general documentation about your project. Jira, bug tracking, feature tracking. Stash is source code management. People that are familiar with GitHub, it's basically GitHub, but local. Bamboo is the continuous build system that we have. Every time you do commit, Bamboo will notice that there's a commit done to a particular repository and will build it. And I'll show you examples of all these things in a second. Crowd is account management. If you go there, you can change your password. All the systems use Crowd as their centralized username and password database. If you change your password, I think it gets applied, well, it's noticeable immediately there. If I add you to a new group, it might take 30 minutes before it's propagated to all the systems. Jenkins is another build system that we have, but I'm slowly migrating most of the things that we are building there to Bamboo because it's better integrated with the rest of the Atlassian stack. And Nexus is the name and artifact repository. So whenever we build something in Bamboo, it immediately pushes a jar file to this Maven, to Nexus, to the Maven repository, so that when somebody else does a Maven and gets the dependencies they need, they will fetch it from there. The follow people have asked to be able to add a web space as well. And so, talking a little bit with them, I was thinking they can have a Git repository for web, and they check in their web pages there, and I just every so often check it out into web folder and just allow them to be able to show that. We can start using that for other projects as well. I was talking to Kenton, is Java docs. It'd be nice to, when you do a build, automatically build the Java docs and push them from there, so that when somebody goes there, they have immediately the latest Java docs as well. All right, this is a living document. This is. I'd like to try this way. We've used it now for managed UVs for cyber integrator sprints. It seems to work. I'll show you some of the things that we've done, so why I think it's a good thing. It's not fixed. You know, if there's something you say, you know, I really don't understand why you're doing it this way, talk to us. Maybe you have a better way of doing it. That would be helpful as well. And we can change it as we go. Feel free to contact us. I think I'm fine with having these slides online, so I'll make a PDF and stick them somewhere where people download them on our webpage. That's it, what I have slides-wise. I'm done with my slides. Yay.
All right, let's do questions. Questions? Comment?
Questions, comments, online. I know it's a lot, and so that's why I said I'll send out the slides, but I think it's useful if we try this, because I think it will help our overall source code, our overall process.
So I think a lot of us are doing lots of this already, or parts of it. But I think it was good to just say it out loud, and so that we're all in consensus about this is the way we're going to be doing this.
Just one comment about the license thing.
Yeah.
It's probably not the best idea for everyone. Each person choose which license they think is best. We should have something that we use in general. If it's the NCSA one, right? But we should know what's the expected from what's being here at NCSA and from building the project from here. Not, oh, I think the MIT license cool, so I'll put it there, and maybe it's not what you need.
I would say, for the, this clearly doesn't apply to the UNC guys, but for the NCSA software stuff, just use the NCSA license.
It's the easiest license for other people to use it, with the least number of restrictions. So. And for us to be able to eventually get our code as far and wide as possible, I think it's if there's enough companies that have said they will not touch any GPL code.
It actually hurts us to do that, so yeah, avoid GPL.
So quick note is like in part actually moving into Eclipse license. The main reason is it's very business friendly and industry friendly. That's the only reason. But other projects we have, NCSA UI license. No. And good thing is we already have plenty of study with the OKM about certain license comparability, so we already have the knowledge.
So, I'm going to try to see if I can switch from my slides to full screen.
You want to share your desktop?
Desktop.
Bottom left, little monitor.
Desktop. All right, so quickly a couple places. So Confluence is the wiki. you can see all the spaces that we have, which are all the different projects. Brown Dog, Cyber Integrator, Medici, Polyglot, all have their own spaces. It's your standard feature. I can go into more detail, but play with it and look at that. Everybody has, if they want to, a personal space where you can add your own nodes, blog if you want to. I just need to sometimes use it too if I have some things that I think are interesting for other people. I post them there. Jira, issue tracking. Basically, if you go in with your own name, you see your tasks that are assigned to you, the different projects that you are interested in. If you go to a project, it shows you all the tasks that are there, it shows you what is happening. Here, I'd like to find a specific issue quickly. This is the one that John and I were talking about. Address endpoint for filter by user. The specific task that Chris needed, John took it on himself. You can see here's what is happening. He added a comment to it. Interesting things that you can start seeing is the bamboo branches. I'll click on that, as well as the sprint that we have here. So I'll start with the sprint. This is the visit. This is one of the agile sprints that we have. So we've picked a certain set of tasks that we thought that were needed to be done for Dr. Nam, and he was here. So I was saying we picked on too much, and said these are the tasks that we want to accomplish while he's here for a week. So when you start, you get all your tasks sitting on the left side, right here, and saying here's the tasks that need to be done. So we started off with 25, 29 tasks sitting on the left side. As we're going, we say, I am now working on a specific task. So we take the task and we move it into progress. So Chris is working on this particular task while John is working on this particular task. Once we're finished implementing a task, we move it into the review stage. So this is what we're talking about is when a task is pushed in, we push it into in review. And then finally, when the review is accepted, it goes into done, or it goes back into in progress. It's a review that's objective.
Hey Rob, Chris put a comment in the text, or and I am in the comments about maybe documentation should be part of the review process.
Yes.
Comments.
Comments. That's probably more comments. And so, yes, I agree with him. So there's Jira. Bamboo is our continuous build system. Every time you do a commit, it builds. So you can see here is all the different projects that we have. Cyber Integrator, Daffodil, Angular, MVP, Polyglot, Tupelo. Here's our different plans that we have for building. So Cyber Integrator, we built a server and the Edison particular module for it. In the case of the Cyber Integrator server, this one has branches. You can see there's all these branches that were done. Every time somebody commits to their own branch and pushes it into Stash, into the main thing, we can set up Bamboo to automatically start building it. So when you push something into Stash, it will create a plan and we'll start building it immediately. So as I was saying, if you push something into the map, into a branch onto Stash, into the server, it will start building it. You get an answer back saying yes or no, it's built fine. So for instance, if we look here in the server 450, if I click on it, you can see here's the summary of it. You can see that number 4 filled. And this is a standard thing, I click on it, I can see what happened. It's been failing since number 1. It fills in this particular section of it. Again, I can click on it. Go to the logs, and I can see at the end of the logs that there is an error somewhere. Okay, so here it fails, and somewhere above, here's the test. So this is why it's interesting. This test ran and had an error. So there was a test there. John didn't even know there was a test there. He committed his code and the test failed. And this is why those unit tests actually are really powerful to have. If I go here, if I click on tests, I can see the test result, and I can immediately see this is the particular test that failed. I can open it up, and it gives me a little bit of feedback of why the test failed. This is really, so this hurt the man sense. It immediately, if you name your branches, and this is why our recommendation in Manage is to name your branches after the particular Jira task that you're working on, it links it back in again. So what's nice, I click on it, it jumps back to Jira to that particular task. So I have all the information I need. Pull request, yes, was. So this is a pull request I did earlier with Chris. This is why I was saying this is the second item is actually useful. Chris did a commit, and I looked at it, and I say, you know, this piece of code, can you move this outside of the try catch? You know, you can go on, you can get in a bad situation. He committed it. It works fine. It probably does fine. But having a second set of eyes looking at it, I looked at it and I said, you know, you need to add this particular piece of code here. You need to do this. You can see all my comments here. Chris did an update. He did a second update to it to fix my comments that I had, and I clicked to merge. At that point, it's merged, and now it's in the main. So this is the one that we're talking about. If I look here at the pull request, here's the pull request. John assigned it to 2 people. He said there's 2 reviewers. There's Chris and me. I can look at it. I can look at the diff. This is your answer. This is why we shouldn't make those diffs too big, because I can look at them. I can look at all the files that have changed. I'll look them over. I did most of it already, and I have the instances Chris is looking at as well. I can see all the commits that John did. Once I say, okay, I'm happy with it, I can approve it. Or in this particular case, I am allowed to write into the master as well. Congratulations, John. I can merge it. I have also the option here to immediately delete it. If I check that off, the branch is immediately deleted from Stash as well. So just house cleaning. Merge. At this point, I have merged in his changes into the master. The cool thing is, again, in the end, this is what Luigi was talking about, is if somebody looks at the code and says, I am okay with it, it's recorded here. I know that I was the one that in the end said, I merged it into the master branch. So if something really bad got merged into it, we can sort of go back and say, hey, why did you do that? Idea, I was in a rush. So Stash, what Smoothie was talking about, I have my own space here. This is sort of the Rob Cooper project, and I have an unlimited number of repositories I can create in here. If I look at, if I go back to the project and I say versus, and I want to work on the audio code, I can go to the audio code, I can fork it, upload it, I can fork it, which will put it in my project, first audio, and I can enable fork syncing, which basically means every time a change is pushed into the main repository, it's get synchronized into my repository as well. Only that way. It doesn't automatically go the other way. So I fork the repository, takes a second, and at that point I have in Rob Cooper versus audio, which is a fork of versus audio. Somebody can come in here again and say, like Dave can come here and says, I'm going to fork this one. And this is sort of there is no one main repository. If the main repository never gets updated and mine gets updated frequently, people might start pulling from mine, and sort of by eventually mine becomes the de facto standard main one. From here, if I issue a pull request, there's not really that much interesting to pull. I can pull it back. By default, it will immediately, from my versus audio, make a pull request to the versus audio. So this allows me to pull it back into the master branch of that particular repository. I think that's it that I want to show quickly there. I think I hit most of the highlights there. Hands-on if people have time for it. There is this demo repository that sits in my space. Send it to here. If you go on the web browser to open source NC State Illinois EDU, // and then users Cooper. See a couple of repositories there, and one of them is demo. So you can clone, if you click on the clone, it will give you an HTTP probably set up. So you can just copy that URL. In Eclipse. If you go to Eclipse into the Git repository view, okay, open perspective Git. You can click on one of those icons. I think the second one that's Git at the bottom. Clone a Git repository and add a clone to this view. So you just click on it. Clone URI. Here it is sort of like a code review system as well. If you have it in your copy buffer, it will automatically paste it in there already. It's like which branches you want to check out, your local ones. So pick all of them so you have everything ready to go. At this point, you will see in the Git repositories a new space. You can import projects there. This was saying why it's nice to check in your projects. You can just keep clicking next, finish, and there's demo projects that automatically check out. Java code. And you can see the whole Eclipse interface changing, and now it actually says here my demo project. This is the Maven file I was talking about, and the interesting thing that I have here is that I have my project depends on JUnit. And so what it will do is it will behind the scenes go download the JUnit jar file for me and place it so that it's ready to be used. I use it as a variable here, the version, so that I have an easy way of changing one place, and it might be applicable to multiple plugins. At this point, basically, I have my code. It's ready to use. I can look at it. It's my main file. It's just Java.
Wait, Rob, let's John is out. And wait, continue.
I'll follow.
Okay.
I create a simple test case. And if you want to, you can run the test case by right-clicking on it, saying Run as JUnit test. Make sure you're in the Java view first. Which the package becomes. So if you right-click on it, say run as JUnit test. What it will do is it will test if my code is working. It doesn't. Alright, so you can quickly see that it filled one of my tests. I'm a bad guy. I checked code and it was broken. I should have run the test first. If I click on a specific test that is broken, just click on the test user create. It will jump straight to the place that the unit test is broken. In this case, actually my code is correct. I have a bad test case because I'm checking to see whether or not the email that is passed that I set up here matches the email that I expected it to be. And, well, it's def null at NCSA, and I'll check to see if it's def null at Illinois, which is correct. We fix that. The NCSA to Illinois to the EU. I can rerun the tests. They will succeed. Oh, happy. Huh?
In source test, automatically it's back now, right?
What?
I'm getting an error in the source test for the test cannot be returned to it.
Do you have the Maven repository labeled in your? Did you download the latest version? Do you have the Scala Play installed?
No.
The Play has an issue where the latest Scala IDE breaks Maven. So if you install the latest Scala IDE, it breaks Maven. If you download Milestone release canon of Scala IDE, it actually solves that problem.
Oh, mine is still not.
Then you have to download the Scala Milestone. So if you have the Scala plugin installed, it actually will break. And so you can see here, I fixed my test.
That's a good example of a cheap test, right?
Yes, this is.
Wow.
It runs fast.
Written to no, I'm saying cheap,
yes.
like in not such a good way.
It's not. Right. On top of that,
Written to
let's be honest. This is one of the reasons why people love unit tests, but this I don't think is a good unit test. Right? Call set and then do get and see if that value works. Sorry, but you have to write really bad code for that not to succeed probably. And it actually does cost you some time to actually write that test. Right? There are better tests you can write. But yes. So I can, you want to see it fixed, Luigi? So we can commit this change if we want to. Fix the test. At this point, I have done the commit to my local Git repository. I haven't pushed it out to a remote one. We can see carefully, you can see that in the corner here, there's a little up arrow with the 1 next to it. It means that I have in my local repository one commit sitting that needs to be pushed up to the remote repository. If I do a fetch, I will see a down arrow with a number next to it sometimes. That basically means that there is this many changes that were in the remote repository that were copied to locally that haven't been applied to this folder yet. It sort of gives you an indication that there's a couple of changes that are waiting. If you right click on it, you can click Team, Switch to Other. And it basically brings up this little browser, which if you click on the remote tracking, shows you that there is a test 1 and a test 2. And so say this is why I use it. Switch to new branch. Sorry, I switch to a new branch. The reference that I'm going to follow is remote origin test 1. I'm calling the branch test 1 as well, just to make it easier. So now I have a local branch called test 1 that follows the remote branch called test 1 as well. So any changes that are made to the remote branch test 1 will be pulled into my local branch. If I do again. You broke mine too. And you can see basically the nice thing is now you pulled in, you can, I implemented how to send email. If we want to use, like I said before, I shouldn't be using the system out here. So I really should change it to logging. It's a two-step process. The first thing I'm going to do is I'm going to go to the Maven Tom. To the dependencies. You can see I added one dependency already, mail. I click on add. Now I can say that I want the logging. So I type in logging, and it will go out and try to find him. It doesn't matter. It goes out to all the servers that it knows about and says, do you have any dependencies that have the word logging in it? See, there's many. So comments, dash logging. I know that's the wrong one. If I type this in, I can see the third one is comments dash logging. You can see it's version 1.13. I can change the version if I know a specific version that I want. Say I want version 1.1. I can specify it. I click OK, and it's basically behind the scenes it's downloading it for me. Sure it's cool. And I don't know why. Mine is down there is not too. It doesn't matter. So basically, if you look in the Maven dependencies, there's now a new dependency comments logging. So now the jar file has been downloaded behind the scenes for me. It's been placed in the right folder already. If I go to the main, I can now start using it. And so this is the things that are sort of nice. Log, directory. But I created my log quickly. You see here's the Java docs that I was talking about.
can say log.debug. So now it's listing, instead of using the system out, it's actually using these debug messages. That way, if later on we actually go to production, it's not going to print out 12,000 lines saying sending email to this particular user. I can just turn it off and it will basically show all those messages. Well, if I later on need to go debugging it again, I can turn the debug level on again, and I can basically see all those messages like that. Does that make sense a little bit? This is there, play with it. It's a very simple project. See if you can add this to it. The final thing is there's a pull request that I noticed. Luigi is the reviewer for a pull request. So I would like for you guys to just look at this pull request. So if you go to Stash and to my repository, look at the pull request. It's a very simple pull request. See if this is a correct one. See if you can leave a comment. Figure out how to leave comments here on a specific line. Okay. Let's do it. So you click on this particular test. So now you have the test in there. You have the pull request. And so if you click on div, you actually see the div. And so Luigi already left a comment there. So feel free to answer it or do something. Huh? So you can see Ashwini already is commenting, and Sandeep is already commenting. And so the nice thing is it's a very quick way for people to leave comments for you on a particular line of code. I can reply to it. And the cool thing is this is saved with this particular pull request. And in the future, when we look back at why did this pull request get accepted, we have this history now of what people are talking about. And there's these long discussions about this is good, this is not good, yes, because this is in the specification here. That's why I implemented this particular way, even though the specification might be broken. Right? Sort of have this history of why people are doing certain things and why they accepted it. Once it gets accepted, this stays with it. So later on, we can always go back and say, hey, there's this bug. Did we notice that before? Yes. Oh, hey, wait. Oh, yes, there's this issue, and Nick pointed out that this was done this way because that's how the specification at that particular point in time said it should be done. And we were following the specification. The specification has changed. They may have fixed something. We need to go back and fix everything. We should not go. Does that make sense? I don't know. Does everybody have the merge button or not? But I know one. I think I'm the only one. Yeah, merge it. What do you mean? Huh? You don't have permission to merge it. Yeah. So I think I am the only one who's allowed to write into the master branch. So I am the only one that eventually can accept the. Everybody can approve the pull, or which I think can approve the pull. Anybody that wants to can say, yes, I agree with this pull request. Right, so, really? Yeah, I just think so. If I look at the overview, Hans Brian and Ina approved the pull request, even though they weren't added as reviewers. So this is the nice thing is, even if somebody says, hey, I see this pull request sitting there, and I'm not an official reviewer, they can still look again at this. This is the many eyes look into source code again. Okay? They look at the source code, says, yes, I approve of this pull request. And so it makes Luigi's task easier because, there's already two people that looked at it and said, yes, I agree, even though he never looked at it. And then he can just do more quick glance at it.
And so, like I said, with Chris, we did this, and it helped a lot. It helps to have a second eye just looking at your own code as well. Just to say, hey, if you move this out here, it works better.